So in this example, we are going to work on deriving the equation of a circle. Just a reminder, the conic section that we're talking about obviously is circles. Here's our double right cone and the plane intersecting it. If the plane intersecting the double right cone is parallel to the base, it's going to create a perfect circle, just like this. And that's the conic section we're going to focus on in today's lesson, and we're going to figure out how that equation comes about. So our question is, how can you write an equation in standard form that describes the circle with center 2, -1 and a radius of 3? So what we have here is that circle. Here's our circle. The center here is at 2, -1, and the radius is 3. We can draw the radius of 3 anywhere, but when we draw that radius of 3, and we take note of the point on the circle, that xy coordinate, we can use a right triangle to help us get an equation of this circle. So if you notice that all we did is we drew straight down till we were in line with the circle and straight across. So we have a right triangle. And if we know the side lengths of a right triangle, we can use Pythagorean theorem to work with this. So we know that the hypotenuse is 3, but how do we know how long these sides are? And this point xy could be anywhere. You know, we could have a point down here and our triangle might look a little different, or a point over here and our right triangle could look different. So we're going to find an equation that will work for any point on the circle. So to figure out how long these segments are, we just use subtraction. You know, we know that, let's look at the x first, right here. Here our x is a 2, and then this x coordinate, to find the distance there, we're going to do x minus 2. We just want to find the distance between those two. We're going to throw absolute value bars on those because that will be a positive measurement because it is a side of a triangle. Similarly, this side of our triangle, we've got our y coordinate, and we know that down here we're at a -1. So if we take our y coordinate and subtract a -1, turns into a + 1, throw absolute value bars on it, that will tell us how long this segment is. And because we know that the radius, or not the radius, the hypotenuse of our triangle is 3, we can go ahead and use Pythagorean theorem. Do you guys see that right triangle? If it's helpful, why don't we maybe just draw that off on the side so we can just get a closer look at what we have going on. So here's our hypotenuse of 3. This bottom leg is the absolute value of x minus 2. The side leg is the absolute value of y plus 1. And the 2 and the 1 came from the center of the circle. That's how we knew, you know, what the, in this case, the x value was here, the y value there, all that good stuff. Okay, Pythagorean theorem, a squared plus b squared equals c squared. So we'll take that leg on the bottom, absolute value of x minus 2 squared, plus the absolute value of y plus 1 squared equals our hypotenuse, 3 squared. Well, when we square anything, it turns positive, and at this point, those absolute value bars are not necessary, because if we square an x minus 2 in parentheses, it's going to be positive anyway. So we're just going to switch out those absolute value bars with parentheses. And again, the reason why we're able to do that is because the squaring will keep that positive. Okay, so this is what an equation of a circle looks like right here. What we have is inside the x, x minus, this is our h value, this is our k value, with the center of the circle. Whoa. The center of our circle is the ordered pair h, k. So if you notice, the center of our circle is the ordered pair 2, -1. So it's tricky, right? So x, it looks like a -2 because that's a +2. And then the y is going to be tricky as well. They get to be tricky together. It's a -1 for the y value. We make sure it's a +1 right there. And then the 9, that came from, we took our radius and we squared it. So let's put a big star and write standard form for a circle. This is our standard form equation for a circle. This is what they're all going to look like. X minus h squared plus y minus k squared equals r squared. And again, your h and your k are the center of your circle, and that r is the radius. So there we go. How quick was that? We got our equation of a circle. And you can just see that stems from using the Pythagorean theorem with a triangle within the circle. Look how creative these mathematicians are. All right, so now that we know a little bit more about how to write a circle, let's write an equation of a circle that has a radius of 1.8 and the center is at the origin. So what we know is the center of the circle is at 0, 0. That's our h and our k value, and we know what our radius is 1.8. So if we follow our equation of a circle up here, we're going to say x minus, and then our h is a 0 squared, plus y minus the k, which is a 0 squared, equals 1.8 squared. And then the only time you'll be able to simplify over here any further is if you do have those zeros. X minus 0 is just x squared. Y minus 0 is y. We'll square that. And then the 1.8 squared, we can go ahead and simplify that to a 3.24. That's the equation of a circle where the center is at the origin and the radius is 1.8. Okay, never mind. What would the equation be, or what would be the equation if the center was at -4, 5? All right, so new information. Our center is now at -4, 5. There's our h, there's our k. So when we plug into our equation for a circle, x minus, it's subtraction built in, and then when we minus a -4, that's when it turns plus. So here's where it looks positive, but it's negative on the graph at a -4. So that's how we get that tricky part. Plus, and then y minus our k, which is 5, we square that, and that has to equal your radius squared. Well, we already squared the radius up above, so we get 3.24.